in industry. And it's all geared around helping professionals who want to advance their careers, building those skills and competencies to support organizations in process safety. So a bit about what we're doing. Now, if you don't mind hitting the next slide for me again there, Jamie. Talking a bit about why we're doing this session. So we've just recently made the move to actually start delivering our courses remotely. It's still an instructor-led program. It will always be instructor-led, at least for the near future. Historically, we've only ever delivered in a classroom setting, but one of the beauties of human nature is that necessity is the mother of invention. And as the pandemic struck and as people were hungry for our training programs and wanted access to them from the comfort of their homes where they could be safe and be with their families and be in a good environment to learn, that was what pushed us to actually start doing remote training. So we've delivered several remote training courses so far, and you can see that we're off to a really great start. It's working really well, and people are still getting good value from the activity, from the training courses. So as you're participating in the session today, you're going to get a look at the fundamentals of risk-based process safety, which is one of our very popular courses. But you're also going to get a look at how we are approaching remote training. And there might be some things you can pick up, some things you can learn. Jamie's got some great tools that he uses. You'll see his whiteboard. You'll see him using slides and videos and different mediums to still connect with people, still convey an important message and help enable that learning. And I think I have one more slide to introduce our star for the hour, Mr. Miriam. So Mr. Miriam has been in business now for over 30 years, doing risk consulting. He's been with operating companies, consulting companies. He's worked on onshore oil and gas production, offshore oil and gas production, refining and petrochemical, and has a really wide range and breadth of experience in process safety and helping to build process safety programs and work within process safety programs. So I can't think of anyone better to teach us today the foundations, the fundamentals of risk-based process safety. So Mr. Miriam, please take it away.
All right, thanks a lot, Tim. All right, folks, we have a big group. Oh, I should turn myself on. That's my fancy shutter there for my screen. Yeah, we have a big crowd today. So I just want to go through a couple of things before we start, just to make sure that this runs smoothly and that we maximize the interaction between yourselves and me. With the number of people participating in this course, what I need is, if you have questions, there's two potential paths to bring questions about. If you want to bring questions to the group, you can use the chat function or send emails to info@acm.ca. All right, and Richard will filter through those, and he'll respond to many of them on his own. If it's something where he thinks it's appropriate to share with the group, he'll inform me of that, and I'll try and respond to that one immediately. All right. And at the end, hopefully there'll be some good questions, and Richard will forward those ones to me, and either verbally or through a text, and I'll try and answer those at the end of the session as well. All participants will be muted to keep the background noise to a minimum. I'm sure you've all enjoyed hearing people's dogs barking and cats meowing as you've gone through learnings before. So David Bellier will actively ensure that everyone's muted, just to keep us from having too much background noise. And obviously, for any additional information, please contact Dave Bellier, and he'll be able to give you some further information. Okay, I think we are ready to start the show. Okay, when we're talking about risk-based process safety, it's a focus on factors contributing to low-frequency, high-consequence process events within a company. Now, when we're talking about these, we're talking about things going wrong that have the potential to impact whatever risk receptors the company thinks are important. Now, when I say a risk receptor, that could be health and safety, and that means people, or it could be the environment, or any other elements that the company thinks are important and critical. Based on one of the various methodologies, we will interpret that risk. The one we're going to be using is, or focusing on, is CCPS's risk-based process safety, but we'll be talking about other methodologies as well. We're going to address many of the factors that have contributed to process events in the past. And this can be used as an applied learning tool with almost any process event. And what I'm trying to instill here is that taking some of these learnings and applying them or interpreting them for your own use is highly encouraged. We want to make sure that we give process safety management leaders within companies the tools to help change the culture. And that's really one of the key focuses of this Lunch and Learn session. So key learning number one, most companies already manage some of these activities in process safety management. Sometimes they're called process safety elements or elements. Okay, so let's talk about those methods. Well, the first one we're going to talk about, the structure, is the Guidelines for Risk-Based Process Safety from CCPS, or Center for Chemical Process Safety. I'm glad they have an acronym because trying to say that quickly is very difficult. As you can see here, there's a number of deliverables for risk-based process safety, and they're grouped into 4 main groups, and we'll get to those in a minute. Okay, and just so you understand, it's not the only methodology out there. There's many different ways of implementing process safety management. In this case here, we're showing you a comparison between risk-based process safety and OSHA 1910. And you can see that they're similar in the way they're applying management principles, but the actual focus points are slightly different. There's two important learnings there. One is that using any of these methodologies, one can still implement a good process safety management, manage process safety within their facility effectively. It doesn't require, or I wouldn't say that RBPS is any better than OSHA 1910. So much of it is how you implement it within your facility. But don't be afraid to learn from various methodologies in order to enhance your layout of process safety management. And those ones touched on North American methods. Here you can see we're branching out into the world. And when we talk about Seveso or safety case, we're talking about ones that are used in the UK and offshore, or no, sorry, not the UK, EU and offshore extensively. And you can see here they're being compared with OSHA 1910, a North American-based structure. So we have the opportunity, again, for any company to implement a methodology that they're comfortable with. If you're in the European side, you may be more comfortable implementing something like Seveso, but the results that you would get would be very similar to the other methodologies. Excuse me. So safety case, as I mentioned, is commonly used in the offshore facilities. And I used to work on the East Coast, and this was something that was approached when we were looking at the deployment of the Terra Nova. Okay, now for a little bit of flashback in time, for those with a little more gray hair, they may recall that API RP 750 actually dealt with these issues, and it was deployed, I think, yeah, here it is, 1990, but I think the last update was around, oh, I don't know, 95 or something like that. But when you look back now, that's 25 years ago. But we can see that if you look at the headings there, they're very, very similar to the ones used today. So these aren't new ideas, and we're always finding ways to improve them. Now, stepping a little closer to home, in Canada here, back in 2012, we saw the process safety management standard being deployed by the Canadian Society for Chemical Engineers. And not long after, we came out with CSA Z767-17. And this is the, what do you want to call it, model for Canada. It does parallel very closely with risk-based process safety structure, and I'll be talking about that in a few seconds here. But the key point here is that there's 4 pillars, which we were talking about, or we touched on before, and which we'll get into more detail now. Okay, and when we look at risk-based process safety versus the CSA Z767, we see that they are very, very similar. All right. So one of the takeaways from that is that the publication for risk-based process safety is an excellent reference manual for some of the application of Z767. Okay, now let's get into these pillars that I was talking about before. There's 4 pillars: commitment, understanding, managing, and learning. And I really enjoy talking about this in this structure because this is a wonderful baseline for management discussion. Okay, we're talking 4 sets of deliverables. Each deliverable has sub-deliverables. Okay, so if we can show how we're improving our commitment, making sure that we understand and manage the process risks and learn from any occurrences within our facilities, we are going to be enacting very effective process safety management. Okay, now I've just shown you 3 pillars that look like they're made out of rock or something like that. What do we do with that? Well, let's talk about it. Okay, first one, culture. My second favorite topic, but this one's worthy of a story. I'm also a tradesman, and at one point on the East Coast, we had a shortage of manpower because of things going on in other facilities. So I actually had to throw off my engineer's hat and throw on my tradesman hat and go out and work on the platform, or the FPSO, for a couple of rotations. And when I went out there, it was, for me, just fascinating to get the process safety culture impacting me as a worker. And so when I went out there, at one point, I had a flame detector that I had to do some servicing to. And the flame detector's location was, for lack of a better description, not convenient. Okay, so what I did was I explored the options I had available to me. I could have used a ladder. And remember, this is a floating vessel, so it's moving back and forth. Not my favorite option because I'm relatively close to the edge of the boat. I could have scaffolding built. Well, the problem was there was a lot of congestion below this location. The scaffolding, number one, would have been quite difficult to install and may have had other factors, risk factors that were not desirable. So there was actually a substructure and a walking path up in the structure of the unit, and effectively I'd be walking along an I-beam with another I-beam right above me that I could put fall arrest gear on. And so after exploring those options and discussing it with my lead, I decided that that's the way that I'd move forward. So I went up there, took my tools, put my fall arrest gear around the beam above and walked over and started servicing the flame detector. During the time that I was up there, which I will say 30 minutes, maybe 45 minutes, one operator and 2 maintenance people had walked by. And this is what I found absolutely fascinating. All 3 stopped by, asked what I was doing, asked about, was I doing it in the safest way possible? And after exploring it with me, they were satisfied and they carried on. But that was the best example I can think of safety culture. These people went out of their way just to come over, look what you're doing, and they weren't, being nosy or anything. They were just asking very reasonable questions. And by asking those questions, they were satisfied that I had explored the options available and that I was doing my work in the safest way possible. Now, there's 2 things that could have been going on there. One, they knew that this wasn't part of my regular duties. I was going out there effectively almost the equivalent of a contractor because I was taking on duties that were not in my normal practice. But they had some familiarity that I was qualified, but they wanted to make sure I was doing it safely. That is safety culture. It was a wonderful experience because it showed me that the people that I'm working with on the FPSO were sensitive to ensuring that people are working safely and doing the job properly. And anyway, so that was a wonderful example of safety culture. Let's carry on here. Okay, so compliance, right? When you have procedures for the workers or for the operators, I shouldn't say workers, I should say maintenance people and operators. Operators work too. So they need to comply to those procedures, right? And not take shortcuts just because they don't see there any value to the rule or think it's going to take too much time if they do it that way. Adding that in the leadership level, the idea that compliance to the procedures is priority is tremendously valuable. Being competent. And this is an interesting one because we're not just talking, and I would say arguably we're not focusing on the competency of the operators and the maintenance personnel, although that is important. But it means all the people in all facets of process safety management have competency based on how they impact process safety. And that's a mouthful. That means we have to understand, number one, how people's duties impact process safety and ensure that we have a plan to ensure they stay competent with relation to those duties. Worker involvement, okay? And this is a relationship between leadership and the workers to ensure that they are engaged and valued as part of our process safety management practices. And finally, community engagement. And this one might be a little bit of a curveball for some of you. We're not talking here about community within the plant boundaries. What we're talking about here is a solid and two-way communication between whatever community is outside of the plant boundaries and which potentially will be impacted or which we may require support from inside the plant boundaries. So, when we're talking about emergency response, this is one of the places where engagement is required because we need to make sure that both what could happen and response requirements are discussed and developed between the community and the facility to ensure that when something bad does go wrong, everyone knows what to do and knows who to contact. Okay, on the understanding side, know the process. That is a huge discussion. Trying to gather all the knowledge so you fully understand what your process is doing is critical to being able to do the next step, which is to know your hazards, okay? So gathering that information and having that information up to date and available when you're assessing hazards is critical to successful process safety management. Procedures. Making sure, number one, that you have procedures, number two, that they're accessible, and number three, that they're correct. This is a monumental task that many operations and maintenance groups are always battling, trying to make sure those procedures are up to date and that any modifications that have occurred in the field have been reflected in the procedures so that when you're starting up, shutting down, or operating that equipment, you have guidance on how to do it properly. Practices, making sure that your maintenance and operations personnel understand what best practices are and are drilled in them so that they have the ability to react in a proper manner and execute their tasks in a proper manner to be safe. Asset integrity. Again, this is another one that's quite challenging because we want to make sure that we are maintaining the equipment to a level that is deemed fit for purpose, okay? And every company will have a little bit of a different definition on that, but you're always monitoring to make sure that it is okay to continue operating in with that equipment in the conditions that you're operating it in. And sometimes the solution to that is to replace the equipment. Sometimes the solution is to derate the equipment. There can be many different ways to maintain safety, but we always have to be monitoring and ensuring that we are within those boundaries. Contractors. making sure, number one, that contractors know how to operate safely within your facility, but also make sure that you understand and the contractors understand what to do when things go wrong. Training, and this is training for inside personnel as well as contractors, making sure everybody has appropriate training so they understand what their duties are in relation to process safety. Management of change, too big to not use acronyms there, but management of change has significant risk to process safety, because when we're making changes, we have to make sure we're making informed changes. And the video that we're going to be watching as part of this Lunch and Learn today is going to drive home some of the criticality of management of change. Operational readiness, a very challenging topic, because you have to make sure that prior to shutting down or prior to starting up, you know exactly what to do and how to do it safely. And this requires both diligence and training of the operators to ensure that they can do this effectively. Operator conduct, acting in a professional manner, but also knowing what to do and when to do it, and continually drilling this skill so that the operators have the ability to know what to do when things are operating normally and what to do when things go off the rails. All right. And I think there's one more. Yeah, emergency response. When things do go wrong, both operations and maintenance people know what to do and how to respond. In a lot of cases, some of your maintenance people will also be first responders. So in the event of some type of emergency, they will initiate their response procedures and prepare to try and fight whatever problem there is. Okay, and the last one. Okay. I talked about culture being my second favorite. Auditing is my absolute favorite, and it's not because I've got problems mentally. Auditing to me is a tremendous way of us having the ability to score how we're doing, okay? Auditing says, how are we doing? What do we do next? And everything that I'm going to talk about below auditing in this pillar is driving towards correction based on some type of investigation. All right. And this to me should never be dealt with as a negative. When I'm involved in auditing, I want to go in, interview people, and I want them to come out of that audit and go, wow, that was pretty good. And then when they see the results, go, oh, he's telling me how to do what I'm doing right better. And you always want to do that. You want people to be very forthcoming. You want to know what things are really operating like and find ways to improve, okay? We do not want to create barriers with auditing. What we want to do is improve process safety execution in a facility. And the way we do that is by bringing out and highlighting the positive successes and the next steps forward to get even better. Okay, investigation. When things do go wrong, this is a tremendous opportunity. Obviously, it's bad because you're doing an investigation, but here's an opportunity to say something's bad that's happened. Let's say a pump that's had a catastrophic failure. Investigate it. Why did it have that catastrophic failure? How can we make sure this doesn't happen again at this facility and any of our other facilities? And take the learnings from this investigation and share them throughout the company so that people stay safe. Measure. And this is not measurement necessarily in a numerical form, but have some ability to take and identify through audits or through investigations some of the opportunities available for improvement and be able to score them so that we can prioritize which ones are the most important to do. This is going to result in a significant amount of data to be filtered through, but if we do, it makes sure that what we do is the priorities actions and not necessarily ancillary actions that don't have as much value to us. We want to make sure when we're doing these measurements that it gives us the ability to make a decision later based on the highest priority items from the audit. Review. And this is an interesting one because this if I could, I can't do it physically, but, oh, actually I can. Yeah, this is where we've got the learnings here. We're going to take and review them over here with management in the commitment side, right? And it's an ability, I mean, it's one of those opportunities where the management, senior management side get to see how and what the learning guys have found and be able to respond to it. So from the top down, we're actually going to see awareness and the initiation of corrective actions, okay? And one of the things we want to be able to do in that review, as I was mentioning in the measure side, is make sure that we're highlighting to leadership what are the important findings that we've found, and make sure that those priority findings get highlighted in the review and addressed by leadership. Oh, there we go. Okay, implementation. Once we've gone through the review and we have a battle plan together, we're going to take and implement corrective actions. And then those corrective actions are going to have impact on both our understanding and our managing of the risk. And how do we do that? We do that by taking those and creating improvements from that implementation. And then we're going to do the whole process over again. And this structure is, I really like using stone graphics for this because it can be really rock solid. As you develop it, the ability for errors or slips to make it through the multiple layers of protection available, because training people are going to be reviewing their training scope. Operators are going to be exposed to that training. If they see flaws in the training, they're going to bring it back to the trainers so that they can identify errors that are in there. MOC people are going to look at the procedures when they're initiating some type of change, and maybe they'll detect an error and then they can go back to the trainers. So everything that goes on, there's multiple ways that errors could be detected, and there's multiple ways we can make sure that the events we're trying to protect ourselves from never occur. Whew, that was a lot. Okay, so key learning number 2, risk-based process safety gives us the ability to know what is important, what we were doing right, and how to improve. That is really what the goal is here. So what's this all look like? What I'm going to do is we're going to take a look at this video, and we're going to look at it from a risk-based process safety lens. Okay, it's a fascinating video, but the value we're going to get out of it is not just based on a passive review of the video, but looking at how commitment, understanding, management, and learning apply to this video or sections of this video. All right, let's go.
The Torrance Refinery is a 750-acre facility located just outside of Los Angeles, California. At the time of the explosion, the refinery was owned by ExxonMobil. An important part of the refining process takes place in the facility's fluid catalytic cracker, or FCC unit. In the FCC unit, heavy hydrocarbons from crude oil are broken or cracked into smaller hydrocarbons, which can then be processed into gasoline and other fuel products. The heavy hydrocarbons are first fed into a reactor, where they mix with the catalyst. The heavy liquid hydrocarbons are converted into lighter hydrocarbon vapors as they travel up the reactor. At the top of the reactor, the lighter hydrocarbon vapors are separated from the catalyst. The hydrocarbon vapors then flow to the main distillation column. The catalyst falls down the side of the reactor, where it moves through a slide valve to a piece of equipment called the regenerator. During the reaction, a layer of carbon called coke forms on the catalyst that must be removed. Inside the regenerator, air is added, and the coke on the catalyst is burned off. The catalyst is then fed back to the reactor through a slide valve, and the cycle is repeated. When the coke is burned off the catalyst, this creates products of combustion called flue gas. The flue gas flows out the regenerator and enters a system comprised of multiple pieces of equipment, which remove any remaining catalyst particles present. The regenerator and flue gas system comprise the air side of the FCC unit. The last piece of equipment in the flue gas system is called the electrostatic precipitator, or ESP. The ESP removes small catalyst particles using static electricity. While the ESP is energized, it creates sparks, which are sources of ignition. It is critical that the flammable hydrocarbon.
Okay. We'll carry on with this in a moment, but now what I want to do is talk about what we just saw. Okay, so again, from a risk-based process safety point of view, let's see what the video did. First of all, it developed key process information, okay? That comes under the pillar of understanding. It identified some of the hazards. Again, we're focused on the pillar of understanding. We're creating an investigation here. So investigate what occurred, that's under the pillar of learning. And finally, if we read the final report from CSB, we'd see that there's improvements suggested in this report for other facilities, and that would again come under the pillar of learning. Risk-based process safety is simply a tool to ensure that we have limited gaps in our implementation of process safety. It provides tools necessary to detect and resolve identified gaps as part of continuous improvement. I wish I could instill to you the challenges in this, but don't ever get the illusion that a process is something that's static. There's always things changing. If nothing else, the inside of the pipe is being eaten away, which is changing the dynamics of the probability of some type of leak or rupture. Rotating equipment is always wearing, and that's why we're always making sure that we replace bearings, that we replace seals, that we're doing for the vessels and the piping, we're doing some type of UT to make sure we know how much thinning has occurred. Processes are not static. Even when we shut them down and there's no flow of materials through them, they're still degrading to some extent, and we have to make sure that we're always diligent and focus on continuous improvement in order to detect and correct potential process issues. Key learning number 3, risk-based process safety requires the effective review of large volumes of data, and this would come under the pillar of management. To know the hazards and their associated barriers. All right, and that comes back to this continuous improvement and this diligence. Okay, so now we're going to go back to the video and watch as this process goes from what we'll call a steady state to an upset.
Hydrocarbons in the reactor do not flow into the air side of the FCC unit, as this could create an explosive atmosphere. To avoid this hazard, the 2 slide valves connecting the reactor and regenerator are used to maintain a catalyst barrier between the pieces of equipment. The sequence of events that eventually led to the explosion at the refinery began on Monday, February 16, 2015, when a piece of equipment in the air side of the FCC unit, called the expander, vibrated forcefully enough that the refinery's control system automatically transitioned the FCC unit to a standby mode known as Safe Park. During Safe Park mode, the flow of hydrocarbons into the reactor is turned off. The flow of air into the regenerator is also stopped. The 2 slide valves connecting the reactor and regenerator are closed to ensure a catalyst barrier is maintained. Steam is then forced into the reactor to prevent hydrocarbons in the main distillation column from flowing back inside. The ESP remains energized during Safe Park. 1 slide valve, however, had eroded.
All right. So we're now starting to see the events that led up to the actual loss of containment and the eventual explosion of this system. And I hope I'm not giving away the end of the story to anybody who hasn't seen this before. All right, let's take a look at this. So for part 2 of the CSB video, let's take a look and see what we observed. First of all, it started talking about the sequence of events. Okay, the expander vibrations, and then some of the other things that occurred based on the expander going into safe mode. It talked about some of the potential hazards, in this case here, vibration and potential damage of that vibration to the expander, which is what triggered the safe park. And finally, the safeguards, which was some type of high vibration trip. And this is the interesting part. The high vibration trip resulted in other things being activated. In this case here, the expander goes down, the slide valves go closed to block in the catalyst. But then, because of whatever risk assessment went on before, they said we also need additional protection. So they started injecting steam in to ensure that there's no way that vapors can make it and mix with the air, or hydrocarbon vapors can mix with the air. Now let's take a look at some of the other things that were also highlighted in there as potential gaps, although not said so directly. Was the valve or the catalyst what prevented mixing of the hydrocarbon with the air? That's really not made clear in this video. And I would argue that the CSB investigators had a hard time figuring out what that answer was supposed to be. Was the trip of the expander a safeguard or the cause of the hazard? Again, I think that depends on perspective. The electrostatic precipitator continued to operate during safe park. Okay, even though two safeguards were activated due to the identified hazard of hydrocarbon and air mixing and potential explosion. So I can't explore into this too deeply in a session like this, but it does beg the question, if it was important enough to do those two safeguards and we're tripping out the expander, why wouldn't we shut off the precipitator? And there may be a good reason for it, but it definitely is a question that's worth asking. The real thing I wanted to drive home to you here is that the sequence in this video has provided the audience with the information necessary to understand the existing conditions prior to the process event. And I really like the way CSB does this, because they tend to follow this formula quite consistently in some of their other videos. And I'm just hoping I can give you a little bit more of a process safety lens when you're watching these videos, because they can be very good learning tools that you can take and actually customize and apply at your facilities to help enhance learnings in a multitude of different elements of process safety. Okay, let's carry on with the third part.
Over 6 years of operation, and even though it closed, it could not maintain a catalyst barrier in the reactor. Within 7 minutes of the unit going into safe park, all of the catalyst in the reactor fell through the slide valve into the regenerator. A direct pathway was created for hydrocarbons to flow between the reactor and the regenerator. But the pressure of the steam flowing into the reactor as part of safe park mode was high enough to prevent hydrocarbons in the main column from flowing back inside. With the unit in safe park mode, operators attempted to restart the expander several times, but were unable to do so. Refinery personnel met to identify a strategy to repair the expander and bring the FCC unit back online. Operations personnel predicted the expander could not restart because catalyst had likely accumulated inside. On Tuesday, February 17th, a meeting took place involving a group of refinery personnel. The group discussed a similar expander outage that occurred in 2012, for which the refinery had developed what is called a variance. A variance is a management-approved deviation from procedure. The group decided to use the 2012 variance, which allowed a departure from the typical requirements for isolating the expander. Part of that process involved installing a blind in one of the expander's outlet flanges. On the morning of Wednesday, February 18th, ExxonMobil maintenance attempted to install that blind, but were unable to do so because steam was escaping through the open flange. Steam from the reactor had traveled through the leaking slide valve into the air side of the FCC unit. Using the variance as a guide, the flow of steam into the reactor was decreased in an attempt to reduce the amount escaping from the expander. But the variance did not evaluate whether this flow rate was sufficient to prevent hydrocarbons from flowing into the reactor from the main distillation column. And unknown to the operators, light hydrocarbons from a separate unit had flowed through a leaking heat exchanger into the main column, increasing pressure inside. With the flow of steam reduced and less pressure in the reactor, nothing could prevent the hydrocarbons from flowing back from the main distillation column. The hydrocarbons flowed into the reactor, where they escaped through the leaking slide valve into the air side of the FCC unit. At 8:07 a.m., a maintenance supervisor working in the FCC unit received an alarm on his personal hydrogen sulfide monitor, warning.
All right. Okay, so part 3. Let's see what the CSB guys were doing here. First thing that we can note is that it showed the initiating events that led to the ultimate consequence of the explosion. It had observations on the equipment, both the failure of the expander and the trip, and then the failure of the protective function of the slide valve and the catalyst. But it also showed us many of the human responses that occurred leading up to the actual event, including that final one, which was the detection of gas in the area where the work was being done. Again, it also kind of touched on some potential gaps. When to use a variance and when are conditions outside of the variance's applicability, okay? It didn't specify that, but it begs the question, you know, when something occurs that's outside of what was listed in the variance, what do you do? And again, that maybe partially comes back to humans, it comes back to training. There's many different elements that it impacts. What did the high vapor flow from the expander flange indicate? Well, again, I wonder if there's something in that variance that would say to them, you know, this is based on, you know, cracking the flange and putting the isolation in under normal conditions. Well, when you have steam, significant amount of steam or vapors escaping when you crack the flange, that is not what I would argue is a normal condition for installing a blind. And then what should have occurred prior to reducing steam flow? Well, you know, if this case here, we already said that the catalyst and slide valve were not deemed as adequate based on normal isolation requirements documented. Well, now we're taking one of the protections that was also put in there, which is the steam flow, and we're modifying it. So considerable thought had gone into these protective systems, and now we're defeating them. And we have to wonder whether the ramifications of that were fully understood. So the sequence of the video has provided the audience with the information necessary to understand the escalation of a single equipment failure and the chain of human responses that followed. Tremendous learning. And I hate to break it to you, but for the conclusion of this video, I recommend you go to YouTube or csb.org because we just don't have time today to review the rest of it. Okay, so what have we gone through today? First thing, we talked about the fact that there's different methodologies for applying process safety management. All of them can be valuable to a company. I don't really have a preference for any one of them. Process safety enhances your company's current good practices, and that's really important. You do not want to continue to reinvent the wheel. There's just no real value in scrapping everything you're doing. Take what you're doing right and enhance it. You're always going to get better traction with the employees and with management, because that means the investment you guys have made in process safety up until now has value. Let's just try and find a way to take that value and optimize it. For 4 pillars of risk-based process safety. The first one being commitment, and that's a commitment from management, and it's also a commitment from all the people underneath them. And understanding where you're coming from and where you're trying to get to with your risk. Managing your risk in a way that is effective, and learning from your experiences. And again, I can't drive that learning hard enough, because it gives us the ability to, number one, know where we are. Number two, take that and with the commitment from leadership, understand where we want to get to. And then we reviewed a process incident, identifying the risk-based process safety components. And I hope you found that as effective, and I hope it's motivated you to use your energy to take some of these CCPS videos, which are excellent, and use them to maximize the value of the learnings for your company. Thank you for participating, and now I'm ready to take any questions. Richard, is there any questions that you want to shoot at me?
Thank you very much, Jamie. Yes, we do have a couple of questions here. We have one from Sean in the chat. What you don't measure, you don't improve. So how can safety culture be measured?
Yeah, and that is a good one. And I tried to highlight on that this is not an empirical measuring system. The best analogy I can give for measurement is one which most people are familiar with, and that is, if you take a look at a risk matrices, the escalation of impact is measured in graduations, right? So let's say we're talking about if you have 5 levels of severity to a, let's say, health and safety, starting off with, let's say, something like a first aid and ending with a multiple fatality. Well, it's the same idea when you're grading your success in compliance with different elements of process safety. What we want to do is work with a customer and find a way to create a scorecard for each of their elements that's appropriate to their industry, and then score how much progress they've made on improving their implementation of that element of risk-based process safety, so that they can say, we're at a level 4 or a level 3 right now, and we want to work our way up to a level 5. That's the ultimate goal. But the great thing is, because we have those graduations, you're not just going to go straight for 5. If you're at 3, you're going to say, okay, what do I need to do to make it to level 4? So it sets a very clear set of deliverables to move to the next level of compliance with that element. I hope that answers that reasonably well. Next one, Richard.
And then one more through the email, which was, can you please shed some more light on how each of the elements from risk-based process safety interface with the other elements?
Oh my goodness, you guys are killing me. I can give a couple of examples. That's the best way to go with this, because this is probably one of the most monumental tasks in the management pillar. It is definitely impacting multiple groups. The fact is, most companies' management structures do not match a process safety management requirement structure. So I'm going to give you an example when we're talking about information. So let's talk about information for the operating, or knowledge of operating of the process. Well, if we have a pump, okay, and we use that pump in there, and we've assessed the risk of operating the facility using that pump, the question is, what happens when you go to procure a new pump? You go and order a new pump. Where do you go to get that information? Is that information accurate? Okay, and I'm already starting to branch into 2 or 3 different departments, if you want to call it, because somebody's archived the data of the original pump that went in there. But the question I would first ask is, based on the startup and operation, did they have to make any changes? Did those changes, or the MOC, document the fact that they had to change the seal in there because the seal was incompatible with the process fluids, and they actually had to order a separate seal and install it on the fly in order to ensure that there wouldn't be any loss of containment due to the incompatibility with the fluid. I hope that gives you a picture that here we have procurement involved, we have our local management and change engineering and documentation people involved, document control involved, as well as the original design documentation. Is it being archived and managed in an effective manner so people can find it? I could keep going on, but I think you get the idea here that the task of implementing an element within a company is not a small task. You want to figure out everyone who's impacted by that and ensure that you bring them all up to speed effectively so that the compliance is optimized throughout the company. Any other ones, Richard?
We're just going to take one more in the interest of time, so sorry if we don't get to yours. But we had a question in the chat. Can we use the 4 pillars of RBPS in mitigating the general risk management?
Mitigating the general risk.
Mitigating risk outside of process safety.
Yeah, that's a stretch. This is really focused and designed for process safety. So to try and take your slips, trips, and falls, occupational hazards, and try and incorporate them in here, I think I have to be careful. I think it's possible that you might be able to group that in, or at least find synergies where those efforts for occupational hazards can be combined and worked on together with certain departments so that you have a unified front and a unified message. I would encourage that, but that is almost a collaboration and teamwork that you'd have to have between your occupational safety specialists and your process safety specialists. Now that I start thinking about it, I would highly encourage it, because why would you not do that? Because that minimizes the amount of duplication. So I don't know if I changed my story there halfway through, but it's becoming a better idea the more I think about it. Okay, I am going to jump back to Tim then. Thank you very much. I hope you guys enjoyed this, and I'm really hoping we'll get a chance to do this in the near future.
Excellent. Thank you, Jamie. And we're actually going to take a quick moment. If anyone's following the chat, Luisa Nera, and forgive me if I get your title incorrectly, Luisa, but I believe you're the director for the North America is at the Center for Chemical Process Safety through the AICHE. You're on the line and willing to share maybe a quick couple of comments. If we can give you about 60 seconds. Richard, I think you're the moderator. Are you able to unmute Luisa to make a couple comments?
Luisa should be able to unmute herself.
Okay, can you hear me?
Loud and clear.
Okay, thanks, Tim, and thanks everybody that's staying on the line. I'm the Global Technical Director for CCPS, so I get to travel all over the world except when we have COVID. But I am certainly willing to help answer any questions, Jamie, that you had, or you can have my email address is louna@aiche.org. The risk-based process safety is a very powerful tool. It's to be able to allow all of us to assess where our highest risks are and allocate our resources accordingly. There are a lot of interactions between all of these, and I saw one chat came up on design. Design is under the second foundation block, hazard identification and risk assessment, and also the managing risk block. I really appreciate that you guys are putting the word out about this, and I will help you any way that I can, because our ultimate goal is to prevent incidents, damage to the environment, the assets, and people. So absolutely. I hope that was short enough.
Yeah, that's perfect. Yeah, no, we just had a couple more things to cover. I wish we had more time for you, Luisa. We should have coordinated that better in advance, but maybe next time. Maybe next time.
Next time.
Next time, yeah. So I'll just go through a couple things quickly for those who are left, and thank you for everybody who joined us. I see some people are peeling off. I know probably other meetings to go to. So thank you everyone for your kind attention to our session today. Talking a bit about remote training and the opportunity to continue your personal development programs, your professional development programs, to learn more about process safety and practical applications of the CCPS RBPS program. All of our courses are geared around that philosophy. And Jamie's just flicking through a couple of slides. No, feel free, Jamie, please go on. We've got a wide range of courses available through the Institute, all available now remotely. I think even the next slide, which is the TÜV Rheinland Functional Safety Engineer certification. So for those who are making a career in functional safety, process safety, there are 2 designations that you can achieve through the Institute, one being in process hazards and risk analysis, where you can become a functional safety engineer certified in that area. The other being in the development, the installation, the maintaining and commissioning of safety instrumented systems and SIS. So 2 very prestigious and globally recognized accreditations that people can work on. And if you'll go to the next slide, Jamie, because this is something that was a bit new to us, we decided to offer some cost incentives to encourage people to take this time as we're, hopefully on the tail end of the pandemic and coming out of it, to take some time to continue their professional development programs and leverage these courses. So there are some offers available, and we'll get all this to you folks in an email. So if you're trying to jot this stuff down, don't worry about it too much. Just keep an eye in your inbox, and you'll hear more from us after this. And my final slide, Jamie. For anybody who wants to learn more about the courses that we have, risk consulting services, or our analytics technology, again, we're doing a lot of work right now to help people. It's the right thing to do. We're all in this together through the pandemic and managing all the risks that are popping up because of the changes in the way that we're doing business and the way that facilities are manufacturing their products. Risk Alive is offering a lot of gratis, just non-charge analysis of data. So something that's very easy for operating companies to take on through the Institute. We're going to continue doing these webinars and these kinds of things, and we're just here to help. So always feel free to reach out and keep an eye on your emails, on your LinkedIn. There's going to be a lot more of these sessions coming up, and we're going to continue to share knowledge, share data, share services and thoughts to help us all be safer together. Because if we do it together, we can accomplish a lot. So, thanks everyone for tuning in. Really appreciate it.
All right. Okay, Tim.
Yeah, we can.
I'm going to shut her down, and then if you want, we can do a D stage. Oh, I got lots of people shutting down.